have our lesson on applying the remainder and factor theorems. There are two ways that you can do division when you have polynomial functions. You have long division and you have the synthetic division. Most people will probably choose synthetic division over long division. However, long division has to be used if you have any exponent higher than to the first power. And so I'm going to do long division first. That way you can see how to use it, and it is in the same format as our original long division from elementary. So I've got my formula, my function was originally 5x to the 4th plus 2x cubed minus 9x plus 12. And then they wanted us to divide this by x cubed x squared minus 3x plus 4. So, because we're doing long division, we're going to write it in the form of a long division. So what comes after the division sign goes on the outside. So we have x squared minus 3x plus 4. Then we have our division. And then what comes in front of the division goes inside. 5x to the 4th plus 2x cubed minus. And you'll notice right here that we have a cubed, but then we don't have a squared. So you're going to have to put a 0 x squared, because remember, in standard form it has to go from the highest exponent down to no exponent without any gaps. And so now I can say minus 9x plus 12. Now when you're doing the actual division, we see that there are 3 spots that are out here, and these are individual terms. All right, x squared is a term, 3x is a term, and 4 is a term. So we have 3 terms, and so we need to look 3 terms in. And so our original answer is going to start right here. All right, so I'm going to go ahead and put a line, because right here is where I'm going to put what I'm dividing. And I'm going to show you what I'm going to do. On this, how many, you want to look at the first of both equations, inside and outside. All right, how many x squares, what's left for, when you divide x to the 4th by x squared? Remember, that becomes, you have x to the 4th over x squared. When we do our exponents, x to the 4 minus 2. All right, so that's what we're going to put over here. We're going to say 5x to the 4th divided by x squared. And that's what I did right here, because all I worried about was my x. And we have x squared. So my actual is going to be x squared. We're going to put that in, since we have so many right here, we're going to say x squared in blue, so we can see what the answer is. All right, now when you, 5x squared. When you do the multiplication back, just like in our previous division, you multiply what we have up here times 4, then times 3, and then again times our x squared. And so we have 5x squared times 4 is 20x squared. 5x squared times the negative 3 is a negative 15x cubed. Now remember, because this is x to the 1st, what we do is we add the exponents, so 2 plus 1. All right, and then we have 5 x to the 2 plus 2 power. And just like in a previous division, we always subtract. But because we have so much inside, we have to remember that this negative gets distributed. And so this becomes a minus 5x to the 4th, which will leave us 0. But this, a minus times a positive, gives us a positive. So I can go ahead and rewrite this with it. Now it becomes a positive. So 2 plus 15 gives me 17x cubed. And again, because a minus and times a positive gives me a minus. And so I now have minus 20x squared. And then again, like a previous division, we bring down the next number. And because right now we're working with terms, we have to bring down the next term. So now again, what we do is we look at the 17x cubed, dividing it by x squared, and that's going to give us, again, we're subtracting our bottom exponent from our top exponent, and that gives us 17x is what is left, because 3 minus 2 for the exponent. And again, this is going to be a positive. And so we're going to go ahead and we're going to say 17x times 4 is 68x. 17x times a negative 3x is 51x squared. And then 17x times x squared is 17x cubed. And again, we have to subtract. All right, now I'm going to distribute my negative. So I'm going to go ahead and say, well, this becomes a negative, this becomes a positive, and this becomes a negative. I did that up there, but instead of doing it all at once, I did it each time we went down. So now I can see 17 minus 17 because this is no longer needed because I've already changed. 17 minus 17 again is our 0. A negative 20 plus 51 gives us 31x squared. And a negative 9 minus 68 gives us a negative 77x. Last time we bring down our last term plus 12. Again, we're going to come up here and we're going to say, okay, well this time I have 31x squared divided by x squared. So we can say x to the 2 minus 2 power gives us 0. And anything to the 0 power gives us 1. And so therefore we are only going to need 31. We're going to do our multiplication. 31 times 4 gives us 124. 31 times a negative 3x gives us a negative 93x. And then 31 times x squared gives us 31x squared. And our last time of remembering that we have to subtract all. And so we're going to distribute our negative inside, so that becomes a negative, this becomes a positive, and this becomes a negative. And we can cancel out our negatives since we distributed. And what is left is we have, that again is our 0, a negative 77 plus 93 gives us 16x. A positive 12 minus 124 gives us a negative 112. And again, in our basic long division, our remainder goes over what we originally divided out. So we would say plus 16x minus 112 over x squared minus 3x plus 4. And that right there is your answer to the long division of 5x to the 4th plus 2x cubed minus 9x plus 12 when we divide by x squared minus 3x plus 4. As previously stated, there are two ways to divide polynomial functions. However, synthetic division can only be used if you have any x to the first power. X to the first power, say plus 5. This number can be anything, but this one has to be to the first. Now, let's go and try to work another division. We have x to the 4th plus 1 divided by x plus 1. So, in this, one thing to keep in mind is right here, if you think back to our last lesson where we talked about synthetic substitution, the number on the outside, this number out here, they just told us when x is 2. All right, well this time, this right here, saying x plus 1, we have to solve that by saying x plus 1 equals 0. We need to get x all by itself. So what we have to do is we have to move our positive 1 to the other side of the equal sign, which means it changes signs. So it becomes x equals a negative 1. Because your operation, the positive, when you move the sign, you have to do the opposite operation, which is our negative. So now we can say our x is a negative 1, so we can put that outside of our synthetic division box. The other thing to keep in mind when you're using synthetic is you have to have standard form, and standard form says you have highest exponent down to no exponent with no gaps. And so if you have a gap, if you have a missing exponent, then you need to put a 0 in that place. And so I'm going to say anything to the just x to any power means 1 times x. So I'm going to say I have 1 as my leading coefficient. I have no x cubed, so I need to go ahead and put a 0 for x cubed. I have no x squared, so I put a 0 for x squared. I have no plain x, x to the first, so I put a 0 in place of x to the first, and then I can put my 1, which is my constant. Just like with our synthetic substitution, the first thing we do is bring our first coefficient down, 1. A negative 1 times 1 is a negative 1. 0 minus 1 is a negative 1. A negative 1 times a negative 1 is a positive 1. 0 minus 1 is 1. A negative 1 times 1 is a negative 1. And then 0 minus 1 is a negative 1. And a negative 1 times a negative 1 is a positive 1. And 1 plus 1 is 2. Now, 2 is your remainder. When you want to write our answer that we've come up with back into equation form, you have to remember that this number that we divided out was one of our x's from our x to the 4th. So therefore we have to subtract 1 from our 4. And so, because this was an x, and so it ends up being x cubed. This, our first coefficient, is now going to be 1x cubed. Then we have, and again, you go down highest exponent to no exponent. So minus 1x squared plus 1x minus 1, with our remainder being a plus 2 over x plus 1. And there is your answer using synthetic division. The next thing we need to talk about as far as applying the remainder and factor theorems, we need to be able to factor the polynomial using synthetic division. So we have an equation that we need to factor, and the equation is y equals x cubed minus 4x squared plus x plus 6, given that x minus 3 is a factor. So, with us knowing x minus 3 is a factor, if you remember back to how we originally solved synthetic division, and it said dividing by x plus 1, we had to get the x by itself. We're going to do the same thing here. We are going to say, well, x minus 3 equals 0. We're going to remember that to get x by itself, we have to move the negative 3 to the other side, and we have to change the operation. So x equals 3. So my 3 will go on the outside of my division box. I have, again, just any x cubed. It means 1x cubed, and then a negative 4. 1, again, because it's just x, and then plus, you don't have to put plus, I'm so sorry, plus 6. All right? The first thing you do, we are going to bring down our first coefficient, which is 1. 3 times 1 is 3. We add inside. Negative 4 plus 3 is a negative 1. We multiply outside. 3 times a negative 1 is a negative 3. We add inside. 1 minus 3 is a negative 2. We multiply outside. 3 times a negative 2 is a negative 6. We add inside. 6 minus 6 is 0. Because my remainder is 0, we can say that 3 is a 0. Now, from there, we can go farther down to find all the other factors. What I'm going to do here, I'm going to do another synthetic box. And I want to think for a moment, this is a factor. So it's a what can be multiplied by something else to get to 2. And so for that regard, we are going to say, okay, well, I can multiply 2 times 1. And so I'm going to go ahead and put a 2 out here. I'm going to bring down my first, and so that's going to give me my 1. 2 times 1 is 2, and negative 1 plus 2 is 1, and then 2 times 1 is 2, and negative 2 minus plus 2 is 0. So again, we have that now 2 is a 0. And then we can do it one more time because we want to get our 1 to equal nothing. And so we can say, okay, well, how about a -1? Because we bring down the first, so that is 1. A -1 times 1 is a -1. 1 minus 1 is 0. So again, -1 is a 0. From all of these, we have right here, all of these are zeros. And so what you can do is rewrite these into factor form. This right here is factor form. So we already have x minus 3. Now we can say, well, if x equals 2, then if I want to get it into factored form, which means everything on one side, I'm going to move this over to the side with my x, which means a +2, change the operation, becomes a -2, so x minus 2. And then again, this one, it originally is saying x equals a -1. We want to move everything to one side. We're going to bring this over. We have to change the operation, and so now it becomes x plus 1. And so your factors for this equation are x minus 3 times x minus 2 times x plus 1.